Okay, like I said, you're allowed to have a cheat sheet on the test, front and back, no worked out problems. Here's the problem we're going to do. Number 1. So it says to solve this system of equations. So notice that we have 2 linear equations. Do you remember how to solve this? Yeah, we actually have 2 different ways of doing this. We have the first way I showed you where you pick one of the equations, you solve for one of the variables, and then you do all that, right? And then the other way was elimination. And that was what we covered the last class we were together. So either one, I'm not going to care on the test which one you use. I'm going to do this one, doing it the first way I showed you. So I'm first going to pick an equation and solve for one of the variables. So I'm going to choose the second equation, and I'm going to solve for x. So I'm going to solve equation 2 for x. So I take negative x plus 3y equals negative 8. 3y plus 8 equals x. So I move the x to the right side, move the negative 8 to the left, which made it positive 8. So now I have an equation for x. What do you do with that? Second step. What do you do? Take that x and plug it into the other equation. So into equation 1, which I'm going to write down, 2x minus, whoa, the wheels are coming off, man. I've never seen that happen before. It's weird, man. All right. 2x minus 5y why are y'all so quiet? Equals 14. And then I plug in 2. Then for x, I'm going to plug in what I just had, right? 3y plus 8. And then I have minus 5y equals 14. So now I have an equation that just has y in it. So the third step is to solve that equation. So distribute through, we get 6y plus 16 minus 5y equals 14. And look at that. 6y minus 5y is y plus 16 equals 14. So y equals negative 2 by subtracting 16 on both sides. That right? And then number 4, step 4, is to take that answer and plug it into to equation 1. So I had 3y plus 8 equals x. So 3 times negative 2 plus 8 equals x. So negative 6 plus 8 equals x. So x is 2. And the way I wanted you to write your final answer is an ordered pair. So your solution is 2, 2. Which one's negative? Oh, yeah, y is negative 2. Thank you. Yes. X, then y. Oh, that is. Well, y was negative 2. X was positive 2. No, it goes in the order. It's always x, y. Mm-hmm. As opposed to just the answer? Yeah, show me the word. It does, I'm sure. But I was in a hurry this morning. All right, number 2. So now we're going to solve a system of linear equations. Linear inequalities. And I say sketch the solution. So the big difference here is that we have the inequality symbols, less than or equal to 4 here. The other one, 3x plus 4y, less than or equal to 18? Right? So inequalities means that our answer is not going to be a point. It's going to involve shading regions of the graph of the plane. So the way to do this was to first switch these into equations, remember? Switch the other one to an equation. Anyone remember what to do now? You can go y equals mx plus b, right? For those who just came in, if you could come up here, there's copies of the review up here. You got one? Okay. Do you have a copy of the review? This one right here. Okay, so you could solve and get y equals mx plus b, right? Or you could also try and get the x-intercepts and y-intercepts. It doesn't matter, but you need to be able to graph these lines. So let's do that first one. 5x minus 2y equals 4. Oh, Izzy, it's okay. It's our last class. I don't know. Do you want to do y equals mx plus b? Really doesn't matter to me. Okay, if we do that, we get negative 2y equals negative 5x plus 4. If I divide both sides by negative 2, I get positive 5 over 2x, and then I get what? Minus 2, right? Let's go ahead and do the other one while we're here. 3x plus 4y equals 18. If I divide, subtract the 3x on both sides, get that. Divide by 4. 18 over 4, that doesn't go in evenly, does it? But it can be reduced to 9 over 2, can it? 18 over 4 is the same as 9 over 2? Are we good? And go to a new page. Oh. Any questions on that? We're okay? Just let me know when. Yep. Okay. All right, so now what we need to do is graph these. So I'm going to cheat here a little bit and try and graph these. All right, so let me do my first line. I have a y-intercept of negative 2. I'll do this one in red. Y-intercept of negative 2. A slope of 5 halves, which means what? How can I get to another point? Up 5 to the right 2. So 1, 2, 3, 4, 5 to the right 2. I could do it again. 1, 2, 3, 4, 5 and to the right 2. Pardon me? We're good? And then we draw a line through that, don't we? All right. So here comes, and is it going to be a solid line or a dotted line? Solid, right? And it's solid just because it was the inequality was less than or equal to, right? Because of the equal sign. Somewhere in here I can change this. All right. So there. Now the other one, where's the y-intercept on the other line? And I'll do this one in blue. 9 halves, which is 4.5. So you might need to get a decimal there. 1, 2, 3, 4.5, right there. And then to get to another point, down 3. So there's 1, there's 2, there's 3 to the right 4. 1, 2, 3, 4. And then draw a line through there. That's it, right? Now, my picture is pretty good because I used graph paper. I can almost tell already where they're going to intersect, right? It looks like it's where? To the right 2, up 3. It looks like 2, 3, but on the test you have to show that. You have to show where they intersect. So you're going to need to label this point for me. Okay, but let's get the shading part of it taken care of first. We need to shade for the, let's say for the red line, we need to shade one side of the red line. Now, how do we figure out which side to shade? Test a point. And which point can we test? 0, 0 will work, right? So let me go ahead and test for the red one. I'm doing it in red. Test 0, 0. And I test it into the original inequality, right? The original inequality was 5x minus 2y less than or equal to 4. If we plug 0, 0 in, we get 0 minus 0 less than or equal to 4. Is 0 less than 4? Yes, so that checks. That means I'm going to shade everything to this side. Are y'all okay with why it's that side? Because that's the side that 0, 0 lives on, right? 0, 0 lives right there. That's on the left side of that line, or the top side. You do the same thing for the blue. We test 0, 0 again. If we test 0, 0 into the second inequality, 3x plus 4y less than or equal to 18, we get 0 plus 0 is less than or equal to 18. That's true, right? So that means I will shade which side of the blue? Bottom side. So this side. And our solution region is where they overlap, right? Which is that, if you look at this as being 4 different sections, right? If I were to actually label this like section 1, section 2, section 3, section 4, it would be that 4th section, wouldn't it? You don't have to label them. I'm just trying to help you see it. So what I would like for you to see on the test is for you to come in here and shade this like that. And of course, it goes forever, right? Like that. But that's good enough. And now just find that intersection point. So how do you find the intersection point? To find intersection, you're going to set up that system of inequalities, but you're going to look at them as being equations. And then it's just like number 1, isn't it? You'll do this just like number 1? Yeah, but yeah, I'm going to do elimination this time. That way we've done one of each today. Well, I think this one will work better with elimination, won't it? So what I'm going to do is I'm going to look at my x's and see if I add straight down, do my x's cancel? No. If I add straight down, do my y's cancel? Not right off the bat, right? But I can make a slight change. I can make this negative 2y into a what? We need it to be a what to cancel with a negative 4y, right? So I will multiply that entire row, or that entire equation by, not negative 2, sorry, by 2. And this will create a new equation. Remember that 2 goes through the entire way, right? And now you add straight down. So if we add straight down, we get 13x equals, well, equals 26. Right, because the y's cancel. I'm adding straight down. Add straight down. And now when I say 13x equals 26, I can divide both sides by 13 and get 2. Once you know what x is, what can you do to get y? Plug it to any of them, right? Remember I said any of the equations? So I'm just going to grab that first equation, 5x minus 2y equals 4, and I'm going to replace my x with 2, which gives me 10 minus 2y equals 4. If I solve that for y by subtracting 10 on both sides, I get negative 2y equals negative 6, and that means y is 3. So x is 2, y is 3. Are we okay with this? Okay. Okay. Now, I'm just going to go back up to my picture, and all I'm going to do is label that point 2, 3. So that's what I would expect to see on the test right there. Now, if you wanted to not have these shaded parts, you could take those out. Okay, that would be fine. Does everyone understand what the expectation is, though, on that problem? Okay. Questions? Okay. Next one. All right, for number 3, (2x plus 3y less than or equal to 12), 2x plus y less than or equal to 8, x greater than or equal to 0, y greater than or equal to 0. So if I took off the x greater than or equal to 0 and the y greater than or equal to 0, if I took those out, I would have exactly like the problem we just did, right? So the last two inequalities there, all that does is adds kind of a restriction to where we can shade. And remember what I said in class, x greater than 0, right? X greater than or equal to 0 means everything to the right of the y-axis, doesn't it? That's what x greater than or equal to 0 means. And y being greater than or equal to 0 means everything above the x-axis, which means we're looking to shade only stuff that lives what we call the first quadrant, which is the top right. If you look at the grid, the x-y axes, the top right is called the first quadrant. So our final shading, our final picture can only live in there. Just keep that in mind, okay? So what I'm going to do with everything else, turn this into an equation. Turn the other one to an equation. And this one, I'd like to, instead of saying y equals mx plus b, like we did in the previous problem, I'm going to do these I'm going to plot these lines by getting the intercepts instead. So I'm not going to solve for y. So how do you find the x-intercepts for this line? Set y equal to 0. So if I let y be 0 in that equation, don't I get 2x equals 12? Which means x is 6. So I have an x-intercept of 6. How do you find your y-intercepts? X is 0. If I let x be 0, I get 3y equals 12, which means y is 4. Now, it would not have worked that easy in the previous problem. That's why it was easier to do it y equals mx plus b. For that particular one, it works nice because everything divides evenly. Okay, how about the other one? What would the x-intercept here be? Yep, 2x is 8, which means x is 4. The y-intercept, set x to 0, which means y is 8. So you're done. Does it make me feel better? No. No. Yeah, thank you though. I appreciate it. Everyone okay? Yeah. I'm gonna start graphing this now. All right, so the first one, the x-intercept was 6, the y was 4. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. So my first line goes through those. If you want to bring a straight edge to the final, damn, that was pretty good first try. If you want to bring a straight edge, yeah, not a shank. That's not what I mean. If you'd like to bring a ruler to the final, you can. If not, you can do the poor man's ruler, right? Fold a piece of paper a few times. Okay, the other one, what were the x-intercepts? So I don't have to go back there. What was it? What was the x-intercept on the other line? What was it? 4 was the x. X was 4 and y was 8. Okay, 1, 2, 3, 4. X was 4, y was 8. 1, 2, 3, 4, 5, 6, 7, 8. And then draw your line. It looks like they hit at 3, 2, doesn't it? But you have to show it, and we'll do that later. Now let's plug in our test points. For the black line, which is the first equation, let's test 0, 0, right? And if you test 0, 0 into the first inequality, which was 2x plus 3y less than or equal to 12, then you get true, right? It works. So I'm going to shade everything below the black line. And then for the blue, you test 0, 0 again. And that's 2x plus y less than or equal to 8. That's 0 less than or equal to 8. That's true. So everything on this side of the blue line. And then the x greater than or equal to 0 and the y greater than or equal to 0, I have not drawn those in there. I think in class I did. But what I was really trying to get you to see is that our answer is just in the first quadrant. It's where they overlap it in the first quadrant, which would only be this section here, right? Be right in here like this. I don't think I can get down in there. Right in there like that. Right? Y'all see that? Just be careful because on the test, if I were to somehow in these problems, just for the sake of seeing if you understand this, instead of using the less than or equal to sign, if I use just less than on, let's say, one of the equations, then that line is going to need to be what? Dotted, okay? Or dashed, okay? Just make sure because I'm going to put at least one dashed dotted line on the test. It's just when I made this, I forgot. Questions? Let's find that intersection point and be done with this. So for that intersection, I need to look at where those two hit each other. So where does the 2x plus 3y equals 12 and 2x plus y equals 8, where do those hit? Which way would you like to do this? I don't care. Elimination or substitution? Elimination? You want to do the bottom one times -1. That's fine with me. So we have 2x plus 3y equals 12. Negative 2x minus y is -8. Now we add straight down and get 2y equals 4, which means y is 2. Take that answer, plug it into any equation. So I'll plug it into this one right here, the second one. 2x plus y equals 8. Replace y with 2. Two x equals 6. X is 3. Is it what? Oh, no, but I went back to the first equation. I could have gone to this one also, but I chose the first equation. Look, if you take this one and you replace y with 2, you would get negative 2x minus 2 equals -8. Then negative 2x equals -6 by adding 2 on both sides, and you still get x is 3. So no matter what equation you use, you should get x is 3. So I just come back up here and I label this point 3, 2. And I'm done. All right, we're getting there. What time do we end? 10:45. All right. I thought. Okay, number 4. Yes. Yeah, that's what I was going to mention. On the next problem, I'm going to want all these points. But see, they're kind of easy to see because they're on the axes themselves. So like it's kind of obvious that this point 0, 0. This point here is what, 0, 4, and that this one is 4, 0. I'm going to say that on this problem you don't have to label them, but if you do, good. On the next problem you have to label everything. All right, next one. So we have this system, and x plus y. Let's do this. Let's change this problem just by making this one less than 4 instead of less than or equal to. Just so you can see an example of what I'm talking about. X plus 2y, we'll keep that less than or equal to 6. Next one, x minus y, less than or equal to 2. Then x greater than or equal to 0, and y greater than or equal to 0. So remember the bottom two there, all that tells you is that you're in the first quadrant. And now we need to graph the rest of those. So I'm going to go ahead and try and graph them here right now. All right, I'm going to do this first one here. We turn that into an equation, don't we? X plus y equals 4. Can you tell me what the x-intercept is? 4, right? Set y to 0, you get 4. So we get 1, 2, 3, 4. I'm doing this one faster, okay? What's the y-intercept of that one? 4 again. Set x to 0, you get y is 4. Is that all right? Valerie, you're looking at me. Is that okay? All right. And then we draw a dotted, dashed, whatever, line through that. I wonder if I have the ability to make this dashed. Let's see if I can make this dashed. I don't think I have a choice. I can't. All right, so I'm just going to have to draw a dashed one. Jeez. Man. I can't draw a straight line for my life. Okay, there we go. All right, now let's do the next line. Is that all right? Anyone have a question on that? Next one, I turn into an equation, x plus 2y equals 6. What's the x-intercept? 6. 1, 2, 3, 4, 5, 6. Y-intercept? 3. Yes. This next one will not be dotted, it will be solid. Okay. Yeah, I changed it. I switched it on purpose just so you could see an example of one that's dashed. So change it on your sheet. Okay, now we need a solid line through those, right? Now let's go to the last equation, or inequality, and switch it to an equation. What's the x-intercept there? Set y to 0, you get x is 2. What's the y-intercept? Be careful here. -2. Right? The y-intercept, if you set x to 0, you get -y equals 2. Multiply both sides by -1, you get y equals -2. So it's down here. And then you draw a line through those. Now that I kind of have an idea of what this looks like, well, I guess that's it, huh? So you would begin to shade, shade sides of the lines now, test points. I'm not going to do that. I'm just going to shade the region that they have in common, which would be this. Can y'all see that? I'm going to zoom into it so you can see it. Do y'all see that? So we have to figure out a couple of points here. We know the top left corner there. We need to figure out this point. This point. We kind of know what that one is already, and then this point. You see the 5 points that we need to find? 3 of them we just know by looking, right? 3 of them, like this, the origin here, 0, 0, that's no problem. This one here, we know it's 2, 0. And then this one here, we know is 0, 3. The first point, or that point right there, is the intersection of which 2 ones? Of the first equation we had, right? Was it the first and the... No, it was the first and second one, right? That's the intersection of the first and second lines we drew. And then this one is the intersection of the second and the third. Do y'all see that? So that means we have to go solve systems of equations now. The first system we're gonna solve is when we take the first and second equations and solve those together. Any questions? Well, let's see. Let me go back. Let me zoom back out here. The red one we'll call line 1, okay? The green one was line 2, right? And then the last one was line 3. So line 3, line 2, and line 1. So the highlighted in yellow there, that's the intersection of line 1 and 2. Do you see it or not? And then the highlighted in blue is the intersection of line 3 and line, and line 1. That's what you were saying? Yeah, look at that. Do y'all see that? Look at this one. This one right here, that's our first line, right? The red one? So it's the first line and the third line, not the second and third. Critical. I'm glad you caught that. So it's the first and third. All right, so let me set up these systems. I'll do them right up here. The first one I'm going to do is I'm going to take the first and second ones as equations, right? Not inequalities, as equations, and solve this little system. Either way, however you want, substitution, elimination. Any preference? Do y'all care? Or? I'll do this one elimination, the next one. No, I'll do this one substitution, next one elimination. So for this one, I'm going to solve the first one for, let's say, x. So I'm going to take the first equation for x. So I get x equals 4 minus y. I'm going to plug that into the second equation now. So I take x plus 2y equals 6. I'm going to replace the x with 4 minus y. 4 minus y plus 2y equals 6. Solve this equation now. I get y equals 2. Plug that into the first equation. I get x equals 4 minus 2, so x is 2 also. So I know that that point there is the point 2, 2. I mean, I could almost just give you like one of these problems, and it would kind of knock out numbers 1 and 2, right? You know what I'm saying? Like numbers 1 and 2 on the test, the review. You kind of already have to do that in numbers 3 and 4. But I don't want to make like one test on one problem. That's not really a good test. So. And then let me get the other intersection point. So I want the first and third in a system. So I'll do that down here in the bottom left corner. I'm going to do the first, x plus y equals 4, and the third, x minus y equals 2. Do you see why I wanted to do elimination on that one? You see how easy it is if you add down? I'm over here on the left side. See me over here? See if I add down, the y's cancel right away. So I get 2x equals 2, which means x is 1. That doesn't seem right. Hold on. Oh, 2x equals what? 6, which means x is 3. And if x is 3, then you could figure that y is 1. I'm not going to do the work, but is that all right? 3, 1? So this is the point 3, 1. We're almost done, Izzy. We really are. Y'all feel okay with this? Anyone have any issues? All right, let's look at number 5. Write out the first 5 terms of the sequence a sub n equals -1 to the n plus 1 2n plus 1 over n squared. This problem is almost a gimme problem. I mean, there's not much you can do to mess this up. You're going to first find the first term, which means plug 1 in, right, for n, which means -1 to the 1 plus 1, 2 times 1 plus 1 over 1 squared. Now keep in mind that the operation here, I'm going to put it in red, is multiplication. Even though it's not written, that's a multiplication symbol. So what's -1 to the 2? Or what's -1 squared? That'd be 1. Times 2 plus 1 is 3 over 1, which is just 3, right? So we have 3. All you did was plug 1 in there, right? Now find the second term of the sequence, plug in 2. -1 to the 2 plus 1 times 2 times 2 plus 1 over 2 squared. What's -1 to the third power? -1 times, what's 2 times 2 plus 1? 5 over, what's 2 squared? 4. So this is really just -5/4. Okay? Then you get the third one. You do the same thing, and you get 7 over 8. I'm not going to do it, but you just keep plugging in. Then you do the fourth one. You get -9/16. And then you do the fifth one, and you get 11/32. No, it doesn't. I'll go back and look at the homework too, because we never got to look at it. Look, at this problem is just plugging numbers in, right? That's all it is. Do y'all need to see more on that, or are you okay? Yeah, like on the way I wrote it on the page, there's no multiplication, but it's just understood that it's multiplication. All right, number 6. Now I'm going to do this problem, but I want to go back to something from one of our last lectures that we had. What's it? Here we go. All right. So what I had done in class, I still need to go back, is I had shown you a formula of how to create even numbers. 2, 4, 6, 8, 10. And I said the sequence was a sub n equals 2n. That'll create the evens. Then I said to create the odds, subtract 1, and you get 1, 3, 5, 7, right? Then I said if you wanted to create the evens but start at a different place, you just had to take your formula, 2n, and add a number to it to shift it. So instead of starting at 2, if I want to start at 6, I add 4 to that formula. And then this will give us multiples of 5. I'm just showing you stuff we covered already. Then this one was 1, then 3, 9, 27, 81. I showed you that these were powers of 3, and we came up with the formula. Then I showed you a formula of how to create an alternating sequence. That's right. I know. I'm going to help you. Don't worry. Okay, this creates alternating, right? Negative 1 to the n creates alternating starting with the negative. Negative 1 to the n plus 1 creates alternating starting with the positive. Positive, then negative, then positive, then negative. Just keep this in mind, okay? Let's now revisit this problem. When you look at something like this and you're asked for the formula, you do it in kind of pieces. First you look, is it alternating? Yes, right? It's alternating. It starts negative, then goes positive, then negative, then positive. Right? Negative, positive, negative, positive. So how can we create a sequence that starts negative, then goes positive? Well, what we're going to need is a negative 1 to the n. Right? Now, remember, n always starts at 1, right? So if I plug 1 in there, I'm going to get a negative 1. And then when I plug in 2, we'll get positive. So that should give me the alternating part of the sequence, right? Now, since it's a fraction, I put a times there. Now, since it's a fraction, I want you to look at the numerators and tell me if you see a pattern in the numerators. They're odds. No, not forget the denominator right now. Just the numerators. 3, 5, 7, 9. How can we create the odds starting at 3, though, instead of 1? So we had a formula that did this. If we wanted 1, 3, 5, 7, our formula was 2n minus 1. That was our formula. But we want to start at 3. Well, I want to start here instead of here, right? So I need to add 2. I need to add 2, right, to move over. So I go 2n minus 1, but then I just add 2 to it. So what's 2n minus 1 plus 2? What's 2n minus 1 plus 2? 2n plus 1. Think about that. 2n plus 1. What would happen if I plug 1 in? I get 3. What happens if I plug in 2? I get 5. Plug in 3, I get 7. See that? Yeah, if you try and do it all at one time, it gets tough. We'll do another couple of these so that you feel comfortable with them. What about the denominator now? They are multiples of 4. They're also powers of 4, aren't they? So it's 4 to the n. Right? Since they're all powers of 4. When I plug in 1, I want a 4 to the first power. When I plug in 2, I want 4 squared. This is your sequence right here. These problems, there's really not like it's not like a set of steps or anything I can give you. You have to see it. Um, yeah, with the negative out front, it's going to be top or bottom. But remember, when we write this fraction up here, negative 3/4, negative 3/4 is the same as negative 1 times 3/4. So it doesn't matter if we have that negative out front or up on top or on bottom. It'll still give us the alternating. So it's okay. So where's that homework set I gave you right here? Did y'all have trouble with these? Okay, so this is that homework set I gave you. So let me show you how this works, because any of these problems would have been fair game for the final. Yep, so let's look at negative 2, 4, negative 6, 8. So again, if you split this up and you think about it, it's an alternating sequence, right? Starting with the negative. So I know my formula has to have negative 1 to the n, right? Now just look at the numbers. What are the numbers? 2, 4, 6, 8, 10. If it was what? If they were all positive, you wouldn't even put anything. You only put a negative 1 to a power if you have alternating in it. So they're all what? I mean, this formula is what now? How do I get even starting with 2? 2n. Just 2n. Just 2n. That's it. Check it for yourself. Plug in 1, you get negative 2. Plug in 2, you get 4. Look at the next one. It's alternating, isn't it? What's wrong, Sarah? Plug in 1, okay, a sub 1 would be negative 1 to the 1 times 2 times 1. No, you plug in 1, then you plug in 2, then you plug in 3. This first one should be what I get when I plug in 1, the second one when I plug in 2, the third one when I plug in 3, 4, and so on. Does that help? Yeah. Okay. The numbers that were... Oh, no. You're trying to create a formula that creates that sequence as you plug in numbers 1, 2, 3, 4, 5, 6. Okay, so let's look at this next one. This one alternates, right? But it starts with the positive. So anytime you start with the positive, you'll do the negative 1, but to the n plus 1 instead of n. And that you just kind of have to remember. Negative 1 to the n if you want it to start negative. Negative 1 to the n plus 1 if you want it to start positive. Yeah. Yeah, that's fine. What's next? Look at the numerators. Since they're fractions, I'm going to look at are y'all getting cold? Oh, you got to go. Okay. Okay. All right. All right. So look at the numerators. Forget the alternating, okay? Don't look at the minus anymore, okay? Just look at the numerators. What are all the numerators? Ones, right? So my formula needs to have a 1 up there. And then on the bottom, it's the same thing I just gave you a second ago. Aren't those all just powers of 4? So 4 to the n. That's it. negative 2 to the power of n. You can't do it that way. No, because if I have negative 2 to the power n, then if I plug in 1, I get negative 2. If I plug in 2, I get 4. When I plug in 3, I get 8. And so it's not going to give me it's going to start to give me powers of 2 instead of multiples of 2. Okay, let's look at this last one. No alternating, so I'm happy about that. This one was tricky, right? What the hell? I'm kidding. What does it look like the numerators are trying to do? 2, 4, 8, 10. The bottoms look like they're trying to be 5, 7, 11, 13. It looks like even odds except for that damn 2/3, right? But isn't 2/3 6/9? I tricked you. So the numerator's really 2, 4, 6, 8, 10. The denominator's really 5, 7, 9, 11, 13. Isn't it? I just reduced the fraction, which confused you. So my numerator are just even starting where? At 2, right? Even starting at 2. How do I make the even starting at 2? 2n. How do I make odds starting at 5? Okay, 2n minus 1 gives me odds starting at 1. 2n plus 1, we just did a second ago, starts the odds at 3. So 2n plus 3 should be odds starting at 5. I just added 2 more, right? Take this 2n plus 1, right? To start at 1, here's what I have. To start at 3, I had to add 2 to that, remember? And then to start at 5, I need to add 2 more to that. And then check it. Just plug in 1, you'll get 5. So that's it. That's the formula. I don't think that there's anything really else. Yeah. Sorry I missed on Tuesday. I was going to show y'all some other stuff, but happens. Y'all have a good day. Oh, when's our final? All right. Well, that's what I was going to show y'all on Tuesday. Maybe what I'll do is, I'll give you a bonus that's one of these that's a little more challenging. No, you don't like those? I thought you liked those. The bonus graphs, I don't think I have. I don't remember. I have to go look. Did you see anything on grades appear anywhere? No? Then I don't think I have. Oh, those real nice graphs y'all made? No, I have not. Because that was at the end of last Thursday? And then there was, no, it was Tuesday. And then Thanksgiving and everything, I got sick, and then now here I am. So I'll get them done. That's a great question. I don't know. I have to check because, normally when I'd be in my office, because, the finals are like almost 3 hours. So normally when I would be in my office, I'm going to be in a final. So let me think here for a second. I'll send something out. Yeah. But just contact me too. Email me or something if you need to meet with me. Exam